when the derivative does not change signs around a critical point. So let's look at one like this. So my horizontal plateau is right in here. You can see my tangent line is flat, horizontal. Derivative there is 0. If I look at these points along here, my tangent lines would all be going uphill. All positive slopes along here. But same thing here. I'm still increasing after this plateau. I'm still going uphill. So these are all positives. So this, because this is a critical point and my derivative did not change on the other side of it, I've got a plateau. And if you think about one coming like this, there's my horizontal plateau, and here the best I could get it. I didn't make it very horizontal, but that's what it is. So I've got a horizontal tangent line, not a very good one. But here my derivative would be negative because I'm coming downhill. Negative, 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 negative. 0 derivative because I'm flat there. After here I'm still decreasing, so I'm still negative. So it's an instance where it stayed negative all the way up to the critical point and after. So if the sign doesn't change, that's a horizontal plateau. A vertical plateau would look like this. Let's see, how can I get that going? Let's see, I can't draw it. There'll be one in the book, don't worry about it. Alright, the other thing we want to talk about is concavity. Concavity is the curvature of the graph. There's 2 concavities. There's concave up. Up is obviously when it's curved up, concave up. And then there's concave down. So think about this as a cereal bowl up. This one's the cereal bowl flipped over. Concave down. You will get what's called a point of inflection. A point of inflection occurs when the concavity changes direction around a critical point. And what's going to give us information about the point of inflection? It's the sign of the second derivative. The sign of the second derivative indicates direction of concavity. It's kind of important. We'll put a little star by it. Okay? So, in summary here, if the second derivative is positive, then the original function is concave up. If the second derivative is negative, then the original function is concave down. Okay, now that we've got all the vocabulary out of the way, now what your homework's going to be like. We're going to be sketching number line graphs given a function, and then we're going to reverse it. Given some number line graphs, make a sketch of the function. So, here we go. Here's our examples we're going to your homework is going to be based off of. Let's see. So we're going to sketch two number line graphs. Okay. So here's our sketch of f of x. Got our horizontal plateau here at 2. There's our critical point. Okay, the number line graphs look like this. You put all your critical points down along here. This is like your x-axis. So I only have one critical point, 2. And then we have our two lines, our original function and our derivative. So, what we need to do is just first fill in the top row here. All we care about on this is whether f of x is increasing or decreasing. So before the 2, as I go from left to right, I am increasing. So we just show a little arrow as increasing. After the 2, I'm still increasing. If I'm increasing and increasing, and I've got a critical point, that means this critical point is a horizontal plateau. I can see it from the graph. Horizontal plateau. Flat. Now for the derivative, all I care about is whether it's positive or negative. So here the derivative, because this is increasing, would be positive. Here it's still increasing, so it's positive. And because it's a plateau, I know that's a critical point, the derivative will be 0. Because derivatives are zeros at maxes, mins, and horizontal plateaus. Okay, the second number line graph is about concavity. So you put your critical point in. F of x is on the top again, and then the second derivative is down here. So on the first one, I care about whether the function is increasing or decreasing. Now I care about concavity. So up until the 2, this graph would be considered concave down. So I just do this, concave down. After the 2, it's concave up. So I do this. So, and what I want to label here is not only is this spot a horizontal plateau, it's also a point of inflection. That's the only thing we can have here. It's either going to be a point of inflection or it's not. And because the concavity switched, that makes this I'll just call it a PI, a point of inflection. Okay, so second derivative then, because this is concave down, second derivatives are negative. Concave up, it's positive. And if the derivative was 0 here, it's still going to be 0 here. Okay, those are the two number line graphs. We'll do a couple more until you get the hang of it. Usually it's 2 more. Okay, here's our function. It's going to be absolute value. We're going to put this critical point at 2 again. Okay, now the number line graphs. F of x, f prime of x, and then our number line. The only critical point I need is 2, so I need before 2, at 2, and after 2. And again here, on the function, all I care about is increasing or decreasing. Then I'll come back and fill in the middle afterwards. So for this part, all my values are decreasing as I approach 2. So decreasing. Here they are increasing. Okay, so if it's decreasing and then increasing, I know that this is a minimum. But I can also see that it's a cusp. But that is a minimum. It's the lowest point. It's actually a global min. Now, because I know this is decreasing, I know my derivatives are going to be negative. Then they're going to be positive. Here, because it's a cusp, the derivative value would be undefined. But again, the author's using infinity here instead of undefined. I'll take either one. So undefined or infinity. I think he uses infinity because there's an infinite number of tangent lines that can be drawn through that minimum point. So that's a UND/infinity, either one, I don't care. Okay, the second number line graph, concavity in this one. So we've got our 2. Okay, here, this thing is as linear as it gets. There is no concavity. No, none. 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 So, down on second derivative, derivative would be, why do I have 0? Oh, because the derivative, I got it. Because remember, the first derivative is going to be the negative value, and then it's a constant, and when I take the derivative of a constant, it goes to 0. There it is, 0 and 0. If that was undefined here, this is still undefined here. Okay, and like I said, the only thing we want to put here is if it's a point of inflection or not. Well, to be a point of inflection, it's got to switch concavity. Well, there was no concavity to switch, so this is not a point of inflection. So on the first number line graphs, we're going to either have maxes, mins, or plateaus. Here, we're going to have point of inflection or not point of inflection. All right, number 3. Try to get all the goofy stuff out of the way here so you don't get stuck on the homework. Okay, we're going to have a vertical asymptote at 2. Okay, f of x, f prime of x, 2. All right, increasing or decreasing. So before the 2, I am decreasing. After the 2, increasing. Here I can see I've got a vertical asymptote. Derivative would be negative, positive, and definitely undefined. Second number line graph, concavity. Okay, before the 2, I can definitely see this is a concave down. This is a concave up. And again, I said if the concavity switched, it would be a point of inflection. The part I forgot was it has to be a continuous graph to have that. This is not continuous. This is not a point of inflection because the graph isn't continuous. Okay, second derivatives would be negative and positive. The second derivative would be undefined. You can't go from an undefined to a defined value. It's impossible. So if it's undefined in the first table, it's going to be undefined in the second table. Okay, these aren't going to be too bad. They might have seemed a little confusing, but they're not. The ones that are challenging are, given the number line graphs, come back with this sketch, which is what we're going to do right now to finish up. And I've got 2 of these.